Hello everyone, and welcome to our class, BIT 320, Introduction to Programming for Data Science. Since this is my first video for this class, even though we are in week 2, I wanted to begin this video by first introducing myself. So my name is Nizar Dejani, and I will be your instructor for this class. So it's my sincere pleasure to spend the coming few weeks with you, and it's my personal preference that you call me by my first name. So there's no need for doctor, professor, or even mister. In other words, please just call me Nizar. I already posted an introduction about myself in the class introduction discussion forum, so please do the same if you haven't done so already. Now, these introductory posts can help us to learn more about each other, and I certainly would like to get to know you better, and so these introduction posts help to do just that. Now, a little bit about myself. I've been programming applications since 1997, and I've been teaching since 2009. I actually got into teaching by accident. You see, when I began pursuing my PhD degree, I had no intention of teaching with it. I just wanted the knowledge and experience of getting a doctorate degree. And shortly after getting my degree, I found an email in my spam folder from someone called Mark Harmon. Now, normally I just delete spam messages as part of my cleanup email effort. But the name Mark Harmon caught my attention because it means something to me. You see, I'm a big fan of a TV show called NCIS, and the main character, Gibbs, is played by an actor called Mark Harmon. So I was surprised that I got an email from Mark Harmon. Now, of course, it was not the NCIS actor, but just a similarity in names. But to my good luck, when I opened the email, it was from a school dean looking to recruit me as an instructor for a programming class. So I discussed the opportunity with my wife, and we decided to go with it, which I'm glad I did because I've been doing it and loving it since 2009, with no plans in stopping anytime soon. So that's my story of how I got into teaching by accident. Now, one thing I noticed while working with students is that they approach programming classes with a mix of emotions. I mean, some are worried and even afraid, while others are very excited. And then there are, of course, those students who are somewhere along this broad spectrum. Now, regardless which sentiment you're experiencing right now, please rest assured that I'm here to help you succeed in this class and to make it a positive educational experience for you. And this point leads me to what I wanted to discuss next, which is my teaching style. I believe that we all learn through different methods and at different rates as well. Some students like to watch videos, others like to read, some like to see examples, and so on. So this class can offer all of that. I will be creating weekly video tutorials to help you with the course material, as well as the weekly assignments. As for the rate of learning, it will vary from student to student. For me personally, I need to read new material a couple of times for things to sink in. And I also learn better by doing. So for example, when I'm learning a new programming language, I will read a bit on it, watch a few videos, then I start coding a few lines and continue to play with it. But that's just me. And also part of my teaching style is that I allow corrections on assignments. For example, you might submit something that is completely off, or perhaps you misunderstood the assignment's requirements, so you didn't score well on the grade for that particular assignment. So instead of just giving you a low grade and leaving it at that, I will share with you my grading feedback and then ask you to resubmit the assignment once again. Now, I do this for two reasons. The first is that we all learn from our mistakes, and so this approach will help you to learn the material better. And the second reason is that this will also allow you to improve your grade. So I hope that these two things will give you some peace of mind and take off some of the anxiety that you might be feeling about this class. Now, I intend to make a weekly video for this class, and during these videos, I will be covering the weekly material, doing a PowerPoint presentation to cover the theory behind the weekly material, and I will certainly be doing a lot of code examples. I also will be covering the weekly assignments, and I pretty much will be doing the assignments during these videos. Now, this class covers both Python and R, so I will be focusing my examples and effort on Python, and I will leave the R learning and the assignments as a challenge for you. But of course, you may ask me questions about both the Python and the R concepts at any time. Now, I do these videos as a way to help you understand the concepts well, and if you are serious about learning code, please also spend time on your own to practice all the things we learn during these videos. If you just copy what I do, it will not be enough for you to develop and grow as a programmer. So please watch what I do, complete your assignments, but then spend an hour or more each day practicing programming. For example, modify the code in our assignments, give yourself some what if I do this type scenario, And when something doesn't work, please troubleshoot it. This is when the learning truly kicks in. So watch me writing code is helpful, but you also need to play around with it and write code yourself. Okay, now since this is our first video, I wanted to mention that if you need to reach me, the best way is either through the school's email, which is nizar.dejani@my.gcu.edu, or through the chat messenger, and I usually respond within 24 hours to either email or chat messages. Okay, this class is an 8-week class, and we have a lot to learn as we cover both Python and R. Also, each week runs from Monday to Sunday, so this means that assignments are due each week on Sunday by midnight. And if you ever need some extra time for your assignment, please do reach out to me via email, and I will work with you to allow it. Now, having said that, please don't leave your schoolwork to Sunday evening, as that's just poor time management, and you will not gain much knowledge when you attempt to squeeze the assignment work in just such a short period of time. My suggestion is to break up the weekly work over several days. I also believe that you need to practice coding each day for at least 1 hour, at least for the first few months, so you can build and grow your coding skills. And I'm definitely confident you can be excellent programmers. Alright, so now that all the housekeeping items have been covered, let's finally dive into the main core subject of this course, the very popular programming language, Python. Okay, so Python is a very popular high-level programming language. And what does the term high-level actually mean? Well, it means it's written in plain, simple human language, so you and I can type it up and understand it. But computers, on the other hand, they don't understand human language, they only understand one machine language, which is called binary. And this binary language only has 2 characters, 0s and 1s. For example, here are some English characters and their equivalents in binary code. So as you can imagine, it's much easier to write code in plain English than it is to write code using machine language. Another thing to know about Python is that it's an interpreted language. In programming, we can have compiled languages or interpreted languages. Compiled languages basically mean that the source code is compiled into binary code and the output is an executable file that can be run at any time. But an interpreted language will run the code line by line and execute it on the spot. So Python is an interpreted language. Now the pros and cons of compiled versus interpreted is a long discussion, but for now, please know that Python is an interpreted language and its code is executed line by line in sequence from top to bottom. Okay, now I always like to understand how things started out, so let me take you on a very quick history tour to explain how Python came to be. It all started with a Dutch software engineer called Guido van Rossum. He started out as a junior programmer at CWI, which is the National Research Institute for Mathematics and Computer Science in the Netherlands, which is better known by the country name of Holland. Van Rossum and his research team wanted to develop a programming language which would enable people without programming experience, like scientists and data analysts, to start writing computer programs fairly quickly. Now, as you can imagine, Van Rossum also had worked with other programming languages, and he found drawbacks with some of them. So for about a year or so, he worked on creating a new language that filled the need. This took place around the end of the 1980s, and the internet was not yet available. But there existed an online communication tool called Usenet, and Van Rossum posted his work there to distribute Python to the world. And it didn't take long for other programmers around the world to take notice, and eventually Python's popularity gained traction, and Van Rossum became known as the benevolent dictator of Python. Now, Python is a multi-purpose programming language, so you can use it to solve many types of business problems. You can use it in web development, machine learning, artificial intelligence, data science, and automation. And in case you didn't know, Python is very popular in creating famous websites that you might be using on a daily basis, like YouTube, Instagram, and Spotify. Okay, now like many of you, when I first heard of Python, I was surprised by the name, and I wanted to know why and how the creators came up with this particular name. So I went straight to the source and got my answer from an interview conducted with Python's creator. When Guido van Rossum began implementing Python, he was also reading the published scripts from Monty Python's Flying Circus, which was a BBC TV comedy series from the 1970s. Rossum thought he needed a name for his language that was short, unique, and slightly mysterious. So he decided to call the language Python. So there you have it, and now you know why Python is called by that name. Alright, variables. This is a fundamental concept in programming. Variables are the building blocks that enable us to work with data dynamically within our code. So what exactly is a variable? Well, think of it as a named storage location in your computer's memory. It's where we stash data for our programs to use. And what's special is that this data can change as our program runs, hence the name variable. Now, let's talk about how we name these variables. While we have some freedom in naming them, there are certain rules we must follow to keep things organized and understandable. First off, in Python, a variable name has to start with a letter or an underscore. For example, underscore temperature or simply age are two examples of acceptable variable names. But variable names cannot begin with a number, so something like second place is a no-go. Also in Python, variable names can only contain letters, numbers, and underscores. So user underscore name or product123 are both fine. And last but not least, variable names are case sensitive. This means that the variable age with all lowercase letters and age with a capital A and age in all caps, these three variables names are treated as different variables. So please pay attention to upper and lowercase in variable names. And as we work with variables, it's good practice to choose names that make sense and reflect what the variable represents. This makes our code much easier to understand. So while you might name a variable as just the letter X, this particular name might not be helpful in explaining what this variable is used for or what value it might contain. So again, since you have the freedom to name your variables, please name them accordingly and appropriately. I will also talk about different naming conventions in a minute or so. So now that we know what variables are, let's talk about their different data types. In Python, there are four basic built-in data types. We have strings, integers, floats, and booleans. Let's begin with strings. In Python, a string is a sequence of characters enclosed within a single or double quotes. It's used to represent text data. For example, consider the string, "Hello, I am happy today." In Python, this is a string literal, which basically means it's a group of characters within quotes. So it's of the string data type. Now we also have integers. In Python, an integer is a whole number without any decimal points. It can be positive, negative, or 0. Take the number 5543. This is of the integer type in Python because integers are used to represent whole numerical values. Now if you have a number that contains a decimal, then we now are talking about another data type, and this one is called float. In Python, a float represents a numerical value with a decimal point. It can be positive or negative, and we call it a float because the decimal point can float in either direction. For example, consider the float 24.567. In Python, this is a floating point number capable of representing both whole and fractional parts of a number. And the last basic data type in Python is called a boolean. This represents truth or falsity values like true or false. We can always use 0 and 1 to represent 0 for false and 1 for true. Alright, so by now we are familiar with variables and how they are memory addresses which hold values of single items. But what happens when we want to have a variable that stores multiple values at once as one variable? Well, this is where we introduce the concept of a collection. Think of a variable as a storage for single value items, while a collection is a storage for multiple value items. And so lists is one example of a collection, and in Python there are other types of collections like dictionaries, tuples, and sets. Now let's delve into some of the key collection data types in Python. So first up we have lists, and in Python a list is an ordered collection of elements enclosed within square brackets. It's a versatile data structure that can hold a variety of data types. So for example, consider this list that has a collection of names: James, Jack, Lisa, Miranda, Jen. In Python, this is a list literal containing multiple elements separated by commas. And since we learned moments ago that anything surrounded by quotes is a string, then this example is a list of strings. Now having said that though, a single list can contain a mix of data types, not just one data type. So the items in a list can be a mix of strings, integers, and booleans, just as an example. Next, let's discuss dictionaries. A dictionary in Python is a collection of key-value pairs enclosed within curly braces. It allows us to store and retrieve data using the key names. For example, consider this dictionary. Our first key is called make, and its value is Honda. Our next key is called model, and its value is Civic. Our last key is called year, and its value is 2015. Here, each key value pair represents a piece of information about a car. If this is a bit confusing, please don't worry, as we will cover it in great details in a future video. Next, we have tuples. A tuple in Python is an ordered collection of elements enclosed within parentheses. Now, unlike lists, tuples are immutable, meaning their elements cannot be changed once they're defined. For instance, consider the tuple 5, 22, 5, 11, 22. In Python, this is a tuple literal containing multiple elements. And as you can see, some elements are duplicated, which is a feature of tuples to allow duplicate values. And finally, let's talk about sets. A set in Python is an unordered collection of unique elements enclosed within curly braces. Sets are usually for tasks like removing duplicates or performing set operations. An example of a set is Monday, Tuesday, Wednesday. And in Python, this is a set literal containing unique elements without any specific order. Now, one nice cool feature about Python is that there is no command that we have to use to declare a variable. In other programming languages, another nice thing about Python variables is that not only do we not have to declare the type ahead of time, but we can also change the type as well as the value. So once we create a variable name and give it a value, which would tell us the data type, this value is going to change, or it can change because it's a variable, but also I can change the variable type to be something else. And we'll see examples of that also in a little bit. Now, it is also important that we use some sort of a standard when we name our variables, and not just variables but also functions. So there are different naming conventions in the programming world. One of them is the camel casing, the other is Pascal casing, and we also have snake casing. So let's assume that we have a variable called my first name. All right, if we follow the camel casing format, then the first word is all going to be lowercase, and then every other word is going to have the first letter capital, and everything else is going to be lowercase. So my first name is going to have all lower first letters, and then the first name is going to have the first capital letter, and then the next word is going to have the first capital letter as well. So why is this called a camel casing? Well, because camels have humps, and again, this kind of looks like camel and then a hump, camel and then a hump. Okay. Then we move on to the Pascal casing, and basically using the same exact example of my first name, the first letter of every word is going to be capital. So M is capital, F is capital, and N is capital. Then we have snake casing, where everything is in lowercase, and if we have multiple words to join them, we join them using an underscore. Now, the snake casing is the popular or the go-to naming convention in Python language. Is this a must? No, it's not a must. It's not a rule. It's just best programming practices and kind of the culture of Python. Now, it's part of best programming practice to use a naming convention and follow it and stick with it throughout the entire application. Your code is going to look nicer and cleaner and more understandable. And many months down the road, if you look at your own code or someone else reviews your code, it's always nice to have some sort of a standard to follow. So if you have, some variables that sometimes they use Pascal case, and then somewhere else in the application they follow the snake case, and then somewhere else they follow the camel case, it's not going to be clean code. It's not going to be beautiful code. So always strive to follow some sort of a standard. Your company might have a development team that follows Pascal casing, and you might have been used to the snake casing. So again, follow whatever the group that you're working with or whatever team you're in, and see what they follow, and to be consistent, follow whatever they do. You can certainly propose to them that, hey, we are doing Python is more snake case friendly, so let's please switch to snake casing, and try to make the case for it. And if it's acceptable, good for you. But again, try to choose a naming convention and follow it throughout the entire application. Now, just like we talked about variables, and we now know that the value of variables can change because they're called variables, We can also have the opposite, which is constant. So a constant basically is data values that stay the same every time a program is executed. So for example, you remember pi from our math days in high school or middle school? Pi is always going to equal to 3.14, no matter what. Okay, so this is a constant, it doesn't change. Now, the naming convention for constants is to make it all in capital letter. Okay, so as you can see here, pi is spelled pi, but it's capital P, capital I. All right, and since the value doesn't change, then anyone looking at this and seeing that it's all in caps is going to say, okay, this looks like a constant value. Same thing with also, I mean, we can make up our own constants, of course, just like we can make up our own variables. So say you're making an application for Google, and the company name is always going to be Google. It's not going to change. So we have a constant called company_name, and we set it equal to Google. All right. It's just a constant is a variable, but we kind of denote it as a constant just by using all cap letters. Again, constants are all uppercase characters separated by an underscore for multiple words. So if we're programming a game and we want to have a set constant of 3 lives or 3 initial lives, then we can create a constant called number underscore of underscore initial underscore lives. So this constant is going to equal to 3, and since it's all in capital letters, then we can understand immediately by looking at it that this is a constant value. Now, as you create your variables and create your constants, again, we know that we can create them and call them anything we want. However, there is something called reserved words in Python. Now, these reserved words are special words that cannot be used as variable names or as function names. So for example, I can't use the word finally for a variable or a function. I can't use the word import for a variable function. I can't use lambda, none, not, or, pass. So any of these words, these are basically called reserved words, and they cannot be used as any sort of identifier like a variable or a function. And we're going to be using most of these words eventually in our code examples throughout this term. So here's the week 2 page, and it's broken down into multiple parts. We first have our discussion sections, which are topic 2, DQ1, and DQ2. Please refer to the different questions that you have to be prompted for and the answer. And also on the right here, we have some required reading. This one is the chapter 2 in our book, and then we have some reading off the web, some URL links that you can click on and start reading. These are very helpful, so please do follow them. And then the assignment part is broken up into 2 pieces. We have a Python assignment and an R assignment, and that will be usually the case for our weekly assignment. Some of them are going to be the same exact code that you have to write once in Python and once in R. Again, as I said earlier, I will be showing you how to do it in Python, and then you please do the assignment in Python as well, and then figure out how you can do it in R as well. And of course, if you have any questions, please do let me know. The instructions are pretty detailed. You just have to follow them one by one. And once you're done for the Python assignments, you have to create a short voiceover video. You have to save your file as a .py file, and that's what you need to submit. And then you also have to create a short voiceover video to explain what your code is and also to demonstrate the code running. Now, if for whatever reason you have technical issues and you can't record a video, then please do write up a Word document that explains a little bit about your code and your experience running it, and if you have any problems or not. All right, so do this for the Python assignment, and then do pretty much the same thing with the R assignment. All right, and when you're done with the R file, submit the .r file, and also create a short voiceover video. So what is expected to be submitted for this assignment is a .py file with your Python code, as well as a video. Now, the video can be done on loom.com, so you can record your videos explaining the Python code and demonstrating that it's running. And then for the R assignment, also submit a .r file and a video that goes with it, and that video also needs to be done on loom.com. And when all that's done, please zip up all the needed files, the .py, the .r. Also create a Word document that has links to the Loom URLs, one for the Python video and one for the R video. And again, put that in a Word document. And then zip up all these documents together in one zip file, and that's what you need to submit. Alright, so if I scroll up here to the Python assignment, all the instructions are given to us one step at a time. So the very beginning says, other than the math package, no other Python packages can be used for this assignment. Alright, now in Python we have something called libraries or modules. The standard library that comes pre-installed when you install Python has a lot of built-in code, a lot of functions, and so on. But sometimes they're not enough. And instead of us reinventing the wheel, we can basically import existing libraries, third-party libraries that someone already wrote for us, so we don't have to reinvent the wheel and code everything from scratch. And one of those libraries that we're going to be using for this assignment this week is math. We're going to be doing a lot of math calculations, and so instead of, again, reinventing the wheel with basic Python code, we can import the math package, and that's going to help us to do all the calculations that we need for this assignment. Alright, so the instructions here start by saying create 3 numeric variables, x equals 30, y equals 45.25, and z equals 15. And then determine the type of each variable, x, y, and z, and then perform the following computations and also determine the types of each result. We basically have to come up with a sum of x and y, and whatever the result is, we have to put it in the letter a, which is a variable called a. And then we need to do subtraction, x from y, and then the result goes in b. And then we need to multiply x and y, and then put the result in c, and then divide x by z, and the result goes into a variable called d. Okay, so let's start with these instructions first. Now, I'm using an application called Idle. I know the class is saying to use PyCharm, but I use Idle just because it comes pre-installed with a Python download, and it's a very little nifty Python editor. It's not an IDE, it's just this, it pretty much looks like a text editor, but with a little bit more of Python support. So here's what I did for the first few lines of instruction. I defined a variable called x, and I assigned it a value equals to 30. Okay, then I'm going to call a print function. Now the print function is one of those built-in function in Python. Python has a lot of built-in functions, and again, no need to reinvent the wheel, we just use them. Now a function has a name, and then it has parentheses, and in the parentheses we can pass arguments. And the arguments are going to be used as a value so that the print function, or whichever function we're using, can use this value and process it. Okay. Now also in Python, notice that I have some lines that start with the pound sign. Now the pound sign basically is a way to tell the Python interpreter that this is a comment. And comments are not executed, they're just ignored. Alright, but they're good for us human people to, write comments and understand what's happening. And it's part of best programming practices to always comment your code. Even if you think that no one's going to look at your code, even if it's just you, trust me, you do need to comment your code, because I fell into that trap as a junior developer. I'm going to comment my code, once I'm done with the project, but then time is always, tight, and you finish one project, you move on to the next one. And so you never go back and comment your code. So comment as you go along. Now, even if you think I will be able to understand my code, my own code, that's false. Because again, it happened to me where I wrote my own code, and then 6 months later, the client said, we want to do an update, and then I look at my code and I question myself, what was I thinking here? What was I planning on doing here? Again, that's why it's part of best programming practice to basically comment your code. So if you or anyone else takes a look at your code, they can read the comments and understand what's going on. And comments could start at the beginning of the line, or they can also be at anywhere on the line. So anything that comes after the pound sign is going to be considered a comment. All right. Okay, so print is a built-in function in Python, and also type. Type is another built-in function in Python that allows us to return the type of a variable. Okay, and that's what the instruction is asking us to do. So I created a variable called x. I assigned it a value of 30. Okay, remember we had 4 basic data types: strings, integers, floats, and booleans. So this is an example of an integer because it's a whole number, it doesn't have any decimals. So I defined it here. Again, remember when you define a variable in Python, you don't have to specify if it's a string or integer or whatever. Python interpreter is smart enough to say, okay, based on the value, which is 30, which is a whole number, then x should be of the data type integer. So that's what we're confirming here. We're going to print out the data type. So I'm using the print function to capture the type function of the variable x. Okay, so this result will be printed out on the screen or on the console because this is being passed, and whatever gets returned will be outputted using the print function. Then I have another variable called y, and I'm setting it equal to 45.25, which is a float. Now I'm going to print the type of this variable, so it should return a float. Then I have a third value, which is z, and it's equal to 15. I'm going to print its data type and then see what it is. Okay, and then I'm going to perform some basic arithmetic operations. I'm going to add x plus y. So here's x and here's y. I'm going to add them together. Whatever the result is, I'm going to save it to a variable called a, and then I'm going to print. I'm not going to print a, but I'm also going to print the type of a, because that's what the instruction is asking us to do. Then I'm going to do a subtraction problem. Actually, one second. I don't think it's asking us some. Okay, so I need to print just the value and not the type. So I need to correct this. All right. So again, instead of printing the type like I'm doing up here, I'm just going to print the results of A, which is the sum problem, B is a subtraction problem, C is a multiplication problem, and D is a division problem. Okay. So let me run this code. And to run this code, you can go up to the Run menu and then click on Run Module. But notice also there's a keyboard shortcut of F5. So I'm going to run it now from this menu option. But in the future, I will be using the F5 shortcut. Alright, so we get back. Let me push this to the right. And you can see here that the idle shell, basically the command line prompt, is using Python version 3.12.2 because that's what I have installed. Alright, so the print statements, the first one says class int, and that's basically this guy here. Alright, so class int is an integer because 30 is an integer. And then I have a class float, and that is a float. That's what I printed out here. And then class int again because 15 is also a integer data type. Then I have 75.25 and all these values here, which is basically the result of these math problems. Okay, so this is all a good sign because I did not get any errors, and so far so good. So let's go back to the instruction sheet and see what it wants us to do. Alright, so number 1, perform the following commands. Import math. Import is a reserved Python command that imports a library. So this is the name of the library called math. And once you import the library, again called math, then you can call its different methods or its different attributes and use them. So there is an attribute called pi as part of the math library, which we just imported. Okay, then we need to round pi to 3 places past the decimal. If you remember pi from your math days in high school or middle school, the number is 3.14 and then so many numbers after it. Okay, it's like, I don't know, 20 or 30 numbers after the decimal. So we want to round the value of pi to just 3 decimal places. All right, and then we store the result in the rounded pi. So let's take a look at that in the code. All right, let me just uncomment that out. There we go. All right, so I'm going to import the math library. Again, import is a reserved word. And once you have math as the name of the library, then you can call it by its name and then follow the dot notation, and then you could bring up methods that belong to math, or you can bring up attributes that belong to the math library. Okay, so math.py is just going to return the number of pi, which is 3.14 and some other numbers. And whatever that value is, I'm going to store it in a variable called pi. Okay, and then I'm going to print out this variable, and then I need to round that variable. So I'm going to call the round function, which is another built-in function in Python. I'm going to pass it 2 arguments. The first argument is the value that I want to round, and then the second number is how many decimals do I want to round this number to. Okay, so here we're going to see the full value of pi, which is 3 followed by so many numbers. Then I'm going to round pi to the 3rd decimal, and whatever result I get back, I'm going to store it in a variable called rounded pi, and then I'm going to print it out. Okay, and let's also comment this guy out so it doesn't. Alright, just comment it out. Alright, so only this code that's going to run. So I'm going to do F5 now instead of run module. F5, and there we go. So I imported math, so now math.py gave me a value of pi and I printed it out. So here is the value of pi, and you can see it's 3.14 with so many numbers. And then I rounded it to the third decimal point, so you can see now it's point, and then here's 1, here's 2, here's 3 numbers. Okay, that's what the round function does. You can round it. If you don't specify a value here, it's going to round it up to the, well, here, let's test that out. If I just do round pi like that, is it going to run? Yep, it runs, and since I didn't specify the number of digits, then it just gives me nothing after. It just keeps the whole number and ignores the decimal spot. If you want to make it just 2 numbers, so it's just 3.14, which is what we're used to, then if I run this code, and now we get back just 3.14 because we specified that the rounding number is just 2. Alright, let's go back again to the assignment instructions. So we did all that. Okay, then rounded. Okay, create 3 strings called town1, town2, town3 that contains panthers, bulldogs, and pheasants respectively. Then verify their types. So we need to create a variable called town1, set it equal to panthers. Create another variable called town2, set it equal to bulldogs. Create a third string variable called town3 and set equal to pheasants. And then we need to print out their data types, which should be strings. Then we're going to be doing some concatenation. So concatenation basically is when you combine or when you add 2 things to, or add multiple things together. So we're going to concatenate, and again it uses the plus sign. I'm going to concatenate town1 with town2, and then we're going to save the result in a new variable called towns1_2. Then we can also do another concatenation problem where we concatenate or we combine town2 with town3, and then we're going to store the result in a new variable called towns2_3. Then we're going to be doing some slicing. So we're going to extract the first 3 letters of town1. So slicing in Python basically allows you to take part or extract part of a variable. Okay, it's called slicing. So we're going to extract the first 3 letters of town1, and then the first 4 letters of town2, and then the first 2 letters of town3. Okay, and then here it says note the Python numbers starts at 0. So Python and most programming languages have indexes, and index basically are all 0 based. So an index of 0, an index starts at 0, that would be the first thing or the first item or the first element, and then index 1 would be the second element, index 2 would be the third element, and so on. Okay, alright, so let's do these first 4 parts or 4 steps first, and we'll come back to the instructions. Alright, let's get rid of this, comment it out so it doesn't run again. Okay, here's that, and then concatenation, then the extraction, then the printing. Okay, so let's run all that code, or at least explain it first and then run it. Okay, Control 4 to uncomment all this code. Alright, so here I created a new variable called town1. I set it equal to the value panthers, and it's a string variable because it's surrounded by double quotes. In Python you can again make it a double quote or a single quote like that. This would be the same. Alright, but don't mix and match. So like don't make a string that starts with double quotes and then ends with a single quote. Alright, so just be consistent. Alright, and once you define those variables, then don't print the variable value out because we know what they are, but print out the type of the variable, okay, which we've done already before, but this time it's for town1, town2, town3. Alright, then we come to the concatenation part. So I want to concatenate town1, and then I'm going to use the plus operator. Okay, so plus is not just a mathematical operator, but it could also be a concatenation operator. So I'm going to concatenate town1, whatever the value of town1 is, which is panthers. I'm going to concatenate it to whatever the value of town2, which is bulldogs. All right, and then whatever that value is, I'm going to assign it to a new variable called towns1 and 2. Then I'm going to print it out. Then I'm going to do the same thing for towns2 and 3, and then store it in a new variable, then print it out. And then I'm going to do some extraction and so it's saying that extract the first 3 letters of town 1. So here's town 1, here's the name of the variable. Then I'm going to use square brackets, which is the notation for indexing, and I don't want to get one letter, I want to get a range of letters. So within the brackets you can have a single character if you want. Okay, so basically if I just have, let's say 4, then town index 4 is basically going to return whatever the 5th letter of the town 1 value. Why the 5th letter? Because the very first letter, or the very first item, is item number 0. Then we have 1, then we have 2, then we have 3, then we have 4. Okay, so town 4 is basically looking for the index 4 location, which would be first letter, second letter, third letter, fourth letter, fifth letter. Okay, again, just remember that index are 0 based. So if you want just one letter, then you can specify one number for the location. But if you want an index, then we basically have we have a range notation, which is like this. The first number is the starting number, followed by a colon, and then followed by an ending number. Now, one thing you have to know about range notations in Python is that the first number is inclusive, while the last number is not inclusive. So this is a start and this is a stop. And think of it like this. In a real world stop sign in the road, you don't stop at the stop sign, so you don't include the stop sign, but you stop, or technically you're supposed to stop before the stop sign. So that number 3 is not included. So then what is included in the 0 to 3 range? Well, 0 is included, 1 is included, and 2 is included, but we don't include 3. All right. Same thing with here. 0 range 4, 0 is included, 1 is included, 2 is included, 3 is included, but 4 is not. So the stopping number in a range notation in Python is never included. All right. 0 range 2 means that we get the first letter, the second letter, and the third letter, but we don't get the letter in index notation 2. So we get 0 and 1 only. All right. So once you get these values returned, we assign the values into these new variables, and then we print out these variables in these lines. Okay, so let's run them. All right, so all of them are strings, which again is correct because they're all in parentheses and they're all in double quotes. And then here I concatenated panthers and bulldogs, which is town 1, town 2. And then here I concatenate the bulldogs and pheasants, which is town 2 and town 3. If you want to add a space between them, then you can basically try to do this. Just for better notation. Okay, so if I run this again, now I have a space between them. Okay, so I concatenate them. Now what happens if you try to concatenate a string to a number? Okay, let's see if that works. Exactly. We get an error, get a traceback error, and it says you can only concatenate a string, not an integer, to a string. Okay, so that's why, again, this is outside the instructions or the requirements, but since we're here, I wanted to share some more information. So we cannot concatenate, or Python does not allow that we concatenate a string with an integer. Now, if you want to still concatenate an integer but make it a string, what we can do is we can call the str function, which is a built-in function, and this function is str is short for string, and it's basically going to convert whatever we pass here into a string type. So right now this is a integer type, but the string or the str function is going to convert it into a string type. So if I now run this, I should not get an error. And here is the 4 has been concatenated between panthers and bulldogs. All right, so just a little bit of extra information here. All right, so these have been concatenated. Then for the slicing part, the town 1. Okay, so town 1 first of all is panthers. All right, so town 1 start at 0 means we start at P, include P, and then stop at 3. So we need to get 0, 1, 2. We don't include 3, so we just get PAN, and that's exactly what we got here, pan. okay? And then for town 2, which is bulldogs, we need to start at 0, and then we're going to go to 4, but not include 4. So 0, 1, 2, 3. So we get bull, which is correct. And then for town 3, 0 to index 2, and we start at 0, and we get 1, and we don't include 2. So it's just ph, and that's exactly what we get, ph. Alright, so far so good. Let's go back to our instruction sheet again. Now we need to work with lists, and list again is a collection data type. So create a list called list1 that contains the contents of the variables created so far. X, Y, A, B, C, D, town 1, town 2, town 3. And then we also need to create a tuple, okay? So a list and a tuples are two different collections. Create a tuple called tuple1, and it needs to contain the constant of the variables created so far, which is X, Y, Z, A, B, C, D, X, Y, A, B, C, D, town 1, town 2, town 3. And then prove that the 8th items in list and tuple 1 are identical, okay? And then change the 8th item in list 1 to rockets. Then prove that the 8th items in list 1 and tuple are now different. So we're going to create, this list, we're going to create this tuple, and then we're going to prove that the very last item in list 1, which is a list, and tuple 1, which is a tuple, are identical, all right? And then we're going to change the list 1 to rockets, and then prove that the 8th item in list 1 and tuple are now different, because rockets is the last item in list 1, but it's not the same as tuple 1. And then we're going to attempt to change, we're going to test mutability, which is the ability to change something. We're going to test it in tuple, and we're also, we already changed it in tuple. We already changed it in list. Now we're going to try to change it in tuple and see what happens, okay? So let's do that. Let's first, okay, actually now I have to keep everything. Let me take this back. And I have to uncomment all that out now. Actually, I don't need this. Alright, I need the X, Y, A, B, C, D, and towns. Okay, so I need these 3. Actually, I need this. I need this. And I need this. X, Y. And then it said town 1, town 2, and town 3. Okay, here's town 1, town 2, town 3, so I don't need to print those out anymore. Let's comment it out. And I don't need this anymore, and this anymore, so we can comment all that out. Alright, so I'm just keeping the definition of my variables, X, Y, Z, town 1, town 2, town 3, X, Y, Z. What is D? Oh, there we go. Oh, wait a minute. Nah, sorry. Alright, so I just need X, Y. I don't need this, but I do need this. I do need B. I do need C. I do need D. And I need Z as well because that's part of D. Alright, so I have X, Y, Z, A, B, C, D. And town 1, town 2, town 3. Where's town 1, town 2, town 3? There we go, town 1, town 2, town 3. Okay. So I have all the variables. And then let's go all the way down to here. And 4. Alright. So to create a list, give it a name. So that's a variable. And then within brackets, within square brackets, because that's going to tell me this is a list, basically contain all the variables that you want to use, or all the items, or all the elements that you want to use in your list. So this is a list. Why is it a list? Well, first of all, it's a group of items. It's a collection of items, and it's surrounded by brackets. And so in my list, I have X, I have Y, I have A, B, C, D, I have town 1, town 2, town 3. And all this list is called list 1, okay? And I have to verify that it's a list, so I'm going to print type list 1, and I'm going to create a tuple. So the difference between a tuple and a list is that, well, they both store a collection of items. A list uses brackets, while a tuple uses parentheses. The other difference between the two is that I can change items in a list once they've been created, but I cannot do that in a tuple. Okay, so tuples are immutable while a list is mutable. Okay, now once we do that, I'm going to print out their data types, and then I'm going to prove that the eighth items in list 1 and tuple 1 are identical. Now how to do this? Well, basically I'm going to say the way you call items in a list is you call it by the list's name, which is list 1, followed by index notation of the number of the index notation. Okay, so list 17 is not the 7th item, but it's the 8th item. Why is it the 8th item? Because Python starts, or indexing number starts at 0. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7. So the 7th item is the 8th item, because this is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. Alright, so don't forget the 0 starting point. Alright, so list 1, index 7 is going to be the 8th item, and I'm going to set it equal to. Now notice here this is a comparison operator. It's not an equal operator. The equal operator is basically when you want to assign a value to something, but a double equal operator is when you want to compare. It's a comparison operator. Alright, so I'm going to compare the value of whatever gets returned from list 17 to whatever gets returned from tuple 17. Now again, the values are the same for the tuple and for the list. Okay, so town3 is my 8th item. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so actually town2 is bulldogs. Okay, so index 7 is going to be 0, 1, 2, 3, 4, 5, 6, 7. So it's town2, so it should be bulldogs, and it's the same for both of them. Okay, so if list 1 7 is bulldogs and tuple 1 7 is bulldogs, and I'm doing comparison between them, then what should get returned is a true statement, the value true. Okay, and I'm also, to verify this, I'm going to print whatever list 1 7 is, and I'm also going to print whatever tuple 7 is, and I'm going to print what does it mean to have a list 1 7 equals to a tuple 1 7. All right. Then what's going to happen is I want to do a change on the 8th item in list 1 and set it equal to rockets. So again, list 1, we said index 7 is, or the 8th location is town2, which is this guy here, and town2 we said is bulldogs. So what I'm going to do is I want to change the bulldogs value, which is allowed because lists is mutable, and I could change the value of an item once it's been created. So I'm going to change the 8th item, I'm going to change the 8th item in list 1 to rockets. Okay, so first, just to prove it, I'm going to print whatever list 1 is, just to show you that before I make any change, it's still equal to bulldogs. Okay, and then I'm going to do a list 1 7 index 7, I'm sorry, and I'm going to assign it a value of rockets. So this is how you can change a value in a list. You call the location of the element in your list, and then you assign it a value. So this is the assignment operator. This is the equality operator, or the comparison equality operator. Okay, so once I change bulldogs to rockets, then I compare list 1 item 7 to tuple 1 item 7. This should not be true anymore because I only changed the list. I didn't change the tuple. Okay, then I'm going to print list 1 again. So I'm going to see that list 1 item 7 has now rockets instead of bulldogs, and then I'm going to compare them after I made the change, and it should come back as false. All right, then what I'm going to do is I'm going to attempt, okay, I'm going to attempt to change the 8th item in the tuple and set it equal to rockets. So this says you will receive an error. Why am I going to receive an error? Because tuples by definition are immutable. Once you have an item in a tuple, you can't change it. Okay, that's one of the key differences between a list and a tuple. So why have a tuple and a list? Well, because sometimes you want to create a list of items that can be changed, which takes some overhead and some performance hit, while sometimes you have a list of items, a group of items, or a collection of items that you know for sure will always be the same and never change. Okay, maybe for data integrity or something. If that's the case, then use a tuple and don't use a list. Tuple would have, better performance because you're not changing anything to it, and they're stable and it maintains data integrity. So I'm going to attempt to change the 7th item in my tuple 1, not the 7th item, but the index 7 item, which is the 8th item in my tuple 1. And when I try to attempt to do that, because I'm assigning it a new value now, this is going to fail at me and says that, you know, tuples are immutable. All right, so let's run all this code and see what happens. F5. There we go. So it runs some of the code, and at the very end, which is the very last line, I get a traceback error and says that tuple object does not support item assignment. So I cannot assign a value to an existing item because tuples are immutable. All right, and just to see what we get back here, this is the type of a list. It's a list. The type of a tuple is a tuple, and then this 8th item in my, let's push this to the side a bit. The 8th item, which is town2, in both my list and my tuple, is town2, and town2 has a value of bulldogs. So that's why we get bulldogs twice here. And then we get a true because bulldogs, which is the 8th item in that list, is also equal to bulldogs, which is also the 8th item in my tuple. Here is the list before I make a change to it. Now, why is this a list and not a tuple? Well, because it has brackets around it. Tuple has parentheses. So I first printed out my list 1, and you can see all the values here, and bulldogs is still the original value, but then I make a change. I update bulldogs and I set it equal to rockets, and then I print out the entire list again, and now you see that bulldogs has been replaced with rockets. And then I try to check, okay, what's the 8th value of the list 1 versus the 8th value of my tuple 1, and the answer is false because they're not the same anymore, because now the 8th value in list 1 is called rockets, while the 8th value in tuple is still bulldogs. Okay, now this is a list, but again, I'm comparing this list with, where'd it go? With this tuple, okay? And town2 is still at the value of bulldogs. All right, and then I attempt to make the change, and then I get this error yelling at me. So again, the difference between, or the two key differences between lists and tuples is that lists are surrounded by brackets, while tuples are surrounded by parentheses, and lists are mutable, meaning that we can change a value once it's been created, but in a tuple, we cannot change the value once it's created because tuples are immutable. All right, so that pretty much wraps up what I wanted to cover for this week. Again, a lot of stuff to learn. I basically focused on Python, and I will be focusing on Python every week. So you please, again, learn from the Python examples and then try to do the same for the R assignment. And of course, if you have any questions regarding Python, regarding R, please do reach out to me either through the email or through the messenger. And anytime you have a question about our code, please do send me the sample file that you're working with so I can take a look at it and see what's going on. Thank you for watching. I will be seeing you guys in class. Take care and bye for now.